Now let us solve a sum based on variance and standard deviation. As you see, we are given a data in terms of xi and fi. So this is a discrete frequency distribution. To calculate the standard deviation and variance, let us first keep ready the formulae. Alright, so first of all, since we would need mean, so we know that mean is 1 upon n summation of fi xi, and where n itself is summation of fi. So let us take the sum of the fi column, which turns out to be 25. Then we would need a column for product fi xi. So let us form a column of fi xi, and we do the corresponding products. 10 into 2 20, then 20 into 7 140, and so on. So on completing the products, we have to take their sum, which turns out to be 770. Now if you have seen the formula of variance, okay, it has two variants, that is it has two forms, and we have to decide which form to use, and we saw that that has to be decided based on the value of mean, correct? So let us calculate the mean first. Mean is summation of fi xi whole upon n, that is 770 divided by 25, that turns out to be 30.8. and now here we see that 30.8 is not a round figure, it has a decimal part, a fractional part. So therefore we go ahead with the second form of the variance, that is 1 upon n fi xi square minus x bar the whole square, right? So that means now we have to generate the column for summation of fi xi square. So first let us build the column of xi square, that is we merely square the xi terms. So we get 100, 400, 900, 1600 and 2500, which well, here we don't need to add because we have to multiply with fi now. So let us multiply fi and xi square columns. So 100 into 2 gives us 200, then 2800, 7200, 4800 and 12,500. Yes, this is the one which we have to sum up. So on summing up we get 27,500, right? So let us plug in the values in the formula. So we will get the result as 1 upon total number is 25 into summation of fi xi square is 27500 minus mean was 30.8 the whole square, right? So that comes to 1100 minus 948.64, and that in turn is equal to 151.36. So this is the variance, and to get the standard deviation we have to take the square root, which turns out to be approximately 12.3. So that is how we calculate variance and standard deviation. Now you must have seen that if the values of xi and fi are little large, in that case the calculations in the remaining columns may become tedious, we might get large figures. So in that case we can use once again the step deviation method to calculate the mean, right? So let us see what is the effect of step deviation or the change of origin and scale on the calculation of variance and standard deviation. So let us consider that we define a new variable y from the old variable x by change of origin and scale. So when we say that y is x minus a whole upon h, then sigma y the whole square, which is nothing but the variance, because sigma is the square root of variance, hence variance will be the square of sigma. So on right side we are seeing that the variance gets divided by h square and hence taking the square root, if we see the relation in standard deviations, then standard deviation of y will be equal to standard deviation of x divided by just h, because we are taking the square root on both sides. So looking at these formula, it is clear that the variance and standard deviation are affected only because of the scaling factor, that is, they are affected only by the change of scale, but they are not affected by change of origin, because you see in both of these formulae nowhere the small a comes into picture. So it does not matter what value of small a, that is the assumed mean, we use, it just depends on the scaling factor h. So while solving the sums involving large figures, we can solve them by changing the origin and scale to calculate the mean first, and then using these two formulae to calculate the variance as well as standard deviation.